Hello, good day everyone. We are Group 1 and the topics we will be covering today are stress analysis, tolerance and allowances, variable stress analysis, and materials and their properties. I am J. Crystal Sidator and I'll be starting on stress analysis. So first, what is stress? Stress is the amount of internal force that is sustained and exerted on the molecular level between the particles of material. So, pakita ka. Drawing ako. Kung makikita niyo itong drawing. Ito yung force. Para madali nating intindihin. Ito drawing. Ito yung force, tapos yung stress, itong ka-opposite direction. Para madali natin maintindihan. Tapos, ang stress ay denoted as sigma. Yan. So, gusto ko rin sabihin na ang basic unit ng stress ay Pascal or Newton over squared meter. Tsaka may isa pang pwedeng megapascal. Or Newton over squared millimeter. May isa pang English unit na ang tawag dito, PSI or pounds over square inches or feet squared. Yan. Yan yung mga pwedeng gamitin natin. Depende sa hahanapin ng problem. So, ang stress ay hindi lang sa temperature, kundi pwede rin sa temperature. Ang stress ay hindi lang sa ginagamit na external load or force, kundi pwede rin sa temperature or chemical changes. Ito namang elastic stress and viscous plastic stress. Yung elastic stress naman ay temporary deformation, kumbaga ay may limit yung elastic stress. Yung viscous or plastic stress ay may yung deformation ay nagiging permanent. So, yun lang. Next ay type of stress. First ay compressive stress. Forces are compressing the material, essential feature in structural design, has a very positive impact on fatigue performance. Ito yung compressive stress. Kung nakikita niyo, nakaganon yung arrow. Nandun na rin sa word na compressive stress, yung pagka-compress. Para madaling matanda. Tapos, ang example dito ay yung upuan. Kunwari, umupo ka sa upuan, tapos, yung force pa ganon, edi nako-compress nung upuan yung bigat mo pa ganon. Kaya, naiitulak. Sana naintindihan, yun lang.
So the next type of stress is tensile stress. So tensile stress is the resistance of an object to a force that could tear it apart. So since it is the material's resistance to tearing, when we look at the diagram here, Tensile stress is generated when forces of opposite directions are pulling it apart. And we can see that the forces are going in opposite directions and pulling the structure apart, therefore elongating it or making the structure longer. So a classic example of tensile stress is the game of tug of war, where two teams pull a rope apart. So tensile stress is also called as normal stress or tension. Actually, normal stress comprises of the tensile and the compressive stress. The formula to calculate our tensile stress is force over cross-sectional area. Tensile stress may also cause stress corrosion cracking or SCC. And it is the combined influence of tensile stress and a corrosive environment. The required tensile stresses may be in the form of directly applied stresses or residual stresses. So stresses that cause environmental cracking can arise from the following actions. Next slide, please. From residual cold work, welding, grinding, and thermal treatment. And one method of controlling stress corrosion is to, of course, eliminate stress. Our next type of stress is shear stress. So shear stress is the tendency to cut an element by exerting stress on one face and another stress on the other face, and both in opposite directions. So when you look in the diagram, the wooden plates or the wood is experiencing force, and both in opposite directions. So the one on the left is experiencing an upward force, and the one on the right is experiencing a downward force. So let's look at the one on the left first. Since it is experiencing an upward force, an external load is being applied on it upward, the stress or the tensile stress that the wood will exert or experience would be going downward in the opposite direction of the external load or the external force. So when an external force acts on an object, it undergoes deformation. And if the direction of the force is parallel to the plane of the object, then the deformation will be along that plane. So the stress experienced by the object here is shear stress or tangential stress, and it is denoted by the Greek alphabet tau. The SI unit of shear stress is Newton per meter square or Pascal. So shear stress is the resistance generated by the material on a specific cross-sectional point and against the forming of opposite forces on itself or objects or materials that are connected to it. So an example of this is the act of cutting a piece of paper with a scissor, applying opposite forces on its sides that cut the paper material on the point of a cross-section where the shear stress is generated. So our next type of stress is bending stress. Bending stress is the normal stress that an object encounters when it is subjected to a large load at a particular point that causes the object to bend and become fatigued. So bending stress occurs when operating industrial equipment and in concrete and metallic structures when they are subjected to a tensile load. So bending happens along the flexural center. When you look at the diagram here, the flexural center is in the middle. And the area above the flexural center will experience compression, whereas the area below the flexural center will experience tension. So the location of the flexural center depends on the cross-section of the structure or of the object. Here for circular or rectangular or square structures or objects, the flexural center would be in the middle, whereas for other types of objects, the flexural center would not be in the middle. So the formula to calculate our bending stress is sigma, pabalik ng slide. The formula to calculate our bending stress is sigma is equal to mc over I, where m is our bending moment, c is the center distance from the flexural center to the outermost layer, and I is the moment of inertia, which depends on the cross section. And we will see that in the next slide. So these are the different formulas to calculate the moment of inertia based on the given structure or the given object. So next we will have our solve problem.